to solve systems of linear equations in my laboratory. Today I'm going to be having two co-hosts with me, and that is Professor Culver Flores and the other Professor Pagar, or Pagar, or whatever you want to call her. She's very funny. Are you ready to get started? Let's go.
These are the equations that we're going to be starting off with. We have 5x plus 4y plus z equals 14.
And 5x plus 2y equals 3, and 2x plus 5y plus 2z equals 24. So, we're going to be using this equation and this equation first because this one is already solved. So that is our equation number 1 because it doesn't have a z, so we already don't need to solve that. So our two equations are 5x plus 4y plus z equals 14 and 2x plus 5y plus 2z equals 24. And we are going to be multiplying the top equation by -2. The reason we're doing that is because we're trying to get it to be -2z so we can cancel out our z's. So when we do that, we get our new equation is -10x minus 8y minus 2z equals -28 instead of having this equation. So we get to cross out our z, because they cancel out. And then we get, what we do is we take 2 minus 10 and get -8x, and then 5 minus 8. Equations, and we're going to, why? Okay,
Don't look at me.
Okay, these are our two new equations, and we are multiplying the top equation by 3 and the bottom equation by 2 because we're trying to get it to be +6 and -6y. So, once we did that, we got 15x plus 6y equals 9. So, yeah. And then we took -16x minus 6y equals -8. And so we got to cancel out our y because they are 6 minus 6, which is 0. So then, we take 15 plus -16, which is -x. And then we took 9 plus -8, which is 1. Oh, yeah. So then we have -x equals 1. And so then we divide our -1 by 1, and we get x equals -1. And that is how we got the x. Now what I'm going to show you is how you get your other y and z values. Now let's just take it off.
Hey guys, Professor Tara here, and we're going to find some y. So we're going to plug in -1 for x into one of these equations, and we chose 5x plus 2y equals 3. And we're not going to do one of the original equations because if we plug it in, then we'll have two variables, and that's just messy. So no. So we have 5 times -1, which is -5, plus 2y equals 3. So then we're going to add 5 to 3. You get 8, obviously. 2y equals 8 is after that. So then you divide 8 by 2, and you get y equals 4. So there you go.
Hey guys! Z is for Zen, and we're about to find some. Let me just get my marker. Alright. So I set up the equation already. We plugged in our x's and our y's. -1, x, 4, y. Let's do this. 5 times -1, -5. 4 times 4, you guessed it, 16. Then we just brought down the z, carried down to 14. Let's eliminate some stuff. 11, subtract. Bring it over here. 14 minus 11 is 3. Then we got our remainder is this right here, which I rewrote right there. Our Zen, z, is 3. XYZ, more like -1, 4, 3.
Let's ask the students at home if they understood this video.
Yeah!
That's what I thought!
There it is. Going to the next equation.
Okay, so this is our next equation. The maximum production of a soft drink bottling company is 5,000 cartons per day. The company produces regular and diet drinks and must make at least 600 cartons of regular and 1,000 cartons of diet per day. Production costs are $1 per carton of regular and $1.20 per carton of diet. The daily operating budget is $5,400. How many cartons of each type of drink should be produced if the profit is 10 cents per regular and 11 cents per diet?
Okay, so from that problem, we're going to find our constraints. So our first we're going to look at this actually just to kind of help you guys out a little bit. So we made X the number of regular drinks and Y the number of diet drinks. So that's going to play into what we have over here for our constraints. So X, regular drinks, has to be greater than or equal to 600. And diet drinks, Y, has to be greater than or equal to 1,000. This is because there are at least 600 cartons of drinks
regular
per day,
cartons per day
and at least 1,000 cartons of diet. Okay, so now we get down to the ones that are a little bit more tricky. X, regular, and Y, diet. So this one has to do with the price. So X is 1, so it's $1 plus $1.20 for the diet. Has to be less than or equal to the daily budget, which is $5,400. Now, this one has to do with the cartons per day. So we have X plus Y has to be less than or equal to 5,000, which is the amount of cartons that were produced per day. Then we're going to come up to our equation that we're going to use when it comes down to graphing and finding the actual answer. So we're trying to find maximum profit. 10 cents for the regular and 11 cents for the Y are what you get for the maximum profit. So when you add them together and plug in the X and Y that we'll get later on, we'll be able to find what the maximum and minimum profits are.
Hey guys, so now we're going to graph it, and we're going to let's graph this line first. So all Y's are 1,000, so you draw a horizontal line through 1,000, and then all X's are 600, and you're going to draw a line vertical through 600, so we have that, and then we graphed these by finding the X and Y intercepts, so we set them to 0, and we got 5,000 and 5,000 for X plus Y is less than or equal to 5,000. And then we got 4,500 and 5,400 for the X plus 1.2 Y is less than or equal to 5,400. Okay. So to find this next intersection point between Y is greater than or equal to 1,000 and X plus Y is less than or equal to 5,000, we do the same exact thing. We're going to plug 1,000 in for Y, so we worked that out and we got 4,000. And then we're going to plug 4,000 back into X plus Y is less than or equal to 5,000 for X, obviously. And then we got 1,000. So for the intersection point of these two lines, it's 4,000, 1,000.
Kabam!
You're welcome, math!
Okay, so for the rest of these intersection points, which are clearly marked right here with these red dots, they're all going to be, to find the answers, it's all going to be used kind of the same way that we, the method that we use to find these points. So we're not going to go into extreme detail, just because we know you smart pupils out there can figure it out on your own. So, but we will guide you through it. So Tara's going to kind of show you what we did. Let's get to it.
So now we're going to find the intercepts of the lines. So first we're going to do these two lines right here, which are these two equations. So I have the two equations written out here, and then we just set them equal to. And this one I put into y-intercept, slope-intercept, sorry. Y-intercept, yep, okay. Just to make it easier for substitution. So I plugged it in right here. So x plus 1.2 times 5,000 minus x equals 5,400. And then I distributed the 1.2 and I got x plus 6,000 minus 1.2x equals 5,400. And then I combined the x's, so I got negative 0.2 plus 6,000 equals 5,400. And then I subtracted 6,000 and I got negative 0.2x equals negative 6,000. There should be another zero, right? Or no, negative 600. Yeah, that's right. And then you divide negative 600 by negative 0.2 and you get 3,000. And then you're going to plug that one back in. I've just plugged it into that one because that's easiest, so this equation. And you got 3,000 plus y equals 5,000. And then you subtract 3,000 and you get 2,000. So that point right there is 3,000, 2,000. So now we're going to find the intersection point of x is greater than or equal to 600, and then x plus 1.2y is less than or equal to 5,400, which should be pretty easy because we're doing the same thing we've been doing for the last two. So we plug 600 in for x, and we get 600 plus 1.2y equals 5,400. And then we're going to subtract 600 from 5,400. You get 1.2y equals 4,800. And then you divide by 1.2, and you get y equals 4,000. And then we're going to plug it in again, 4,000 in for y. And then we get 600 by working it out. So the intersection point is 600, 4,000.
Hi guys, Maya here. I'm going to teach you how to get the max and minimum profit, but all we really care about is max. So what we do, now that we have our points, we just lay them out all nicely so it's easier to see, and then we're going to plug x and y into c equals 0.10x plus 0.11y. Alright, let's do this. So we plug in 600 times 0.10 and we get 60 plus 440, but we plugged in 4,000 for 0.11y. And then we get 500, same for the rest, and then we get 520, 510, 170. So as you can tell, this is the highest number, so that's our max, and this is the lowest number, so that's our minimum. So now for our conclusion part of it, we have to write the max profit of $520 at 3,000 regular drinks and 2,000 diet drinks. That's it.
This is what happens when you're a camera person. You gotta do the camera work and then she do itself. I'm going